I think it's funny.
Okay,
Okay, John.
I don't think I understand it.
Oh, you don't understand?
Okay, the meme was too memeful for me. Okay. So, here's just a general question for you. I'm going to show you a little animation. The second. Yeah, so just, this is one that you might, this may be obvious to you, maybe not. So maybe you've never thought about it. If you had a wheel, this is a wheel. Let's say the radius was, let's say it's a big wheel, has a 2-foot radius. Okay, or a ball, it can be whatever, just a round object. If it rolled one rotation, so we did one full roll, how far would the center of the circle travel?
Zero.
Oh.
4 feet.
Oh.
4 feet.
2 feet.
IR something.
Oh my goodness. So the answer is 4 pi feet. Because the idea is when you roll, assuming you're not slipping, we're not going to cover that this year. Or every time we're talking about rolling, it's going to be assume the thing rolls smoothly. Because if it slips, like a bowling, when you roll a bowling ball and it kind of slips and slides as it's rolling, that's extremely complicated to analyze. So anyway, so think about a point on the circle. Well, when the thing rolls one full rotation, if you think about it, every single point along this circle has touched the points along the floor. I made a little animation that kind of illustrates this, so we'll look at. So the idea is, well, what's the circumference of the circle? Well, the circumference is 2 pi r. So in this case, it would be 2 pi times the radius of 2. So 4 pi feet is the circumference of the circle. So when it does one full roll, the circle will have traveled 4 pi. Does that general idea make sense?
Yeah.
Okay, so here I'll show you this little thing here. This hopefully it'll make sense what this is showing you. So this circle is rolling, okay, and the red. You can kind of imagine what if the circle painted the ground as it moved? Then that, see the connection there? Hopefully the circumference ends up being the distance traveled. So the circle that I made here has a radius of 2. And when it's rolled that full 2 pi radians, you can see it's got about 12 and a half. And 12 and a half is roughly what 4 pi is, right? 4 times 3.14. Do you feel okay about that? Okay. So let's answer for number 4 then. Or no, we never did 3, so let's do 3 first. So we'll do 3 in. And a quick little review here. So radians are a very powerful mathematical tool because if this is theta and this is the radius, then this arc length here would be just theta times the radius. So that's why radians exist, because they give us this really nice relationship. If theta was in degrees, it's a much more complicated formula. It would be like 2 pi r times theta over 360, which is like a pain to work with. Okay, so for numbers, so now we know with this roly-poly here, the idea would be that the distance, let me draw a picture of this. If you're a roly-poly, the distance you travel, what?
It looks like a bird.
Oh my God.
Owl you showed me a picture of the beavers last week.
It does look like an owl.
What owl is that?
The distance traveled. The distance traveled is like the arc length subtended. So basically, you could say, well, the arc, it's the same idea. It would be how much angle, the rotation angle multiplied by the radius. Does that make sense going from here to here? Yes, hopefully. If not, we can discuss it further. It's fine. Julia, yes, you're here. Mr. Computer said you were gone. Oh. Yay. Oh, someone else corrected it. Okay. They fixed it. All right. Okay, so for number 3, if you traveled, so if I guess number 3 is actually more of a particle traveling around the circle, so it's more like this. Whereas 4 is a roly-poly. So for number 3, what you want to do is say, well, on my circle here, the radius is 5. How many radians would I have to rotate around the circle in order to go 100 meters? Okay. So what's the answer? Well, the arc length, the distance you traveled around the circle, is equal to the angle you went times the radius. We know the radius, right? We're solving for theta. And what's L? 100. So the answer here is 20 radians. How was your sabbatical, Julia?
It was pretty good.
Pretty fun?
Pretty boring.
Boring?
Yes.
Did you go skiing on Friday at least?
Couldn't. My friends wouldn't let me.
Wait, your brother was there?
Yeah, I was quarantined.
Oh, because I
Yeah.
forgot you were
So I had
quarantined.
to stay home.
Dang it!
Yeah.
Sorry,
Very
Julia.
sad.
That's sad. It's terrible. Oh man. Sorry to hear that. Did Ben come home and be like, "Do that on you"? No, good. Ben's a good guy. Okay, sorry. How bigly is 20 radians, roughly? I mean, what is that? What is 20 radians? Anyone? Come on. 60. Well, it's 100 meters. We have that established. It's 100 meters. How many spins? How many spins, roughly? Think about it. How many radians is in one spin? 2 pi, which is roughly 6. So this is like 3 and change. This might be 3 and a little bit extra spins, right?
Yep.
We sure we understand that?
Yes.
So if they give you the number of radians in terms of pi, like say 50 pi, right? 50 pi is 25 spins precisely. But if there's no pi in the number, if it's like 20, you just have to kind of think like, well, one spin is about 6.3-ish, 6.28 radians, so that would be about 3 spins. Okay, I hope that makes sense. Okay, then how many revolutions did the particle make? Let's be precise here. We can say, don't say roughly 3, that just gives us kind of a rough idea. So the number of revolutions would be the number of radians, right? So 20 radians divided by how many radians are in each revolution? 2 pi. So one way to write the answer would be 10 over pi, right? But that number's not like, I mean, it's a fine answer, but in most cases, it makes more sense to be like, well, that's roughly 3.18 revolutions. Yes.
So would you want us to convert it to a decimal then? Or would you be okay with us answering in with pi still in the answer?
Just know both. I mean, if you wrote this as your final answer, I'm not going to like dock you your points or anything.
Okay.
Just understand that, I mean, I've seen this before where students don't understand that this is a number. Like they think, which kind of makes sense. Like it's easy to lose sight of the fact that this just describes a number that can be written in base 10, right? That's so number 4, Mr. Roly-Poly says, if we complete 4 revolutions and that gets us a distance of 10 meters, what does that mean for us? What was the radius of the circle? Or I should have said, what's the radius of the cylinder? Sorry. Might be it. No, there's a few ways you could solve this. Let's try to get to maybe this idea here. Because what we have here is this idea that the number of revolutions is equal to the distance traveled, right? Or sorry, the number of radians. Divided by 2 pi, right? Makes sense. And then we also know that this is true. So you can get the number of radians by dividing the distance traveled divided by the radius. So what's one way you can solve this? Maybe you can go 4 revolutions got us 40 meters. So what's 1 revolution? 10 meters. Okay. So if 1 revolution is 10 meters, and what does 1 revolution correspond to in distance? 2 pi r, right? Circumference in the circle. So 2 pi r is equal to 10 meters. So what's the radius? 5 over pi, which is roughly, what is that, 1 point? Someone, please help, please help.
1.59.
1.59, great. You guys feel okay about that? Does that make sense?
Yes.
All right. Let's look at, we gotta do some vocabulary.
Early bird is still Tuesday. Yeah. Weightlifting.
What?
Weightlifting.
What about early bird?
Oh, well,
They're in charge of what.
yeah, and they always like make it a bench day. It's like, hey guys, you guys are gonna end up with an upper body the size of a rock.
All you gotta do is do bicep curls and bench press. That's all that matters.
Yep.
Don't develop like back muscles. That's dumb. They're pointless. They don't do anything.
Don't worry.
Leg muscles, they don't do anything.
Pull-ups.
Yeah.
All that matters, biceps, triceps.
Right? There's
Yeah.
no need to do anything else.
Get those glamour muscles. That's all that matters.
You forgot the
Other ones
abs.
could actually know
What?
You forgot the abs.
Oh, the abs too. These crunches.
Y'all know abs are.
Okay, so number 5 is about a ball traveling in a circle. I hope one of the things I want to make sure is clear to you guys is like a ball attached to a string traveling in a circular path has a lot of similarities to a rolling cylinder or a rolling ball. Okay, the math is going to be the same because of that fact that the distance you travel is the same as the distance from the circle that's been traveled. So, okay. Anyway, A, B, C, D. We're not going to do them in that exact order, but the radius is 3 meters, and he completes 300 revolutions per minute. Okay, so I need to tell you what a few of these words mean. Frequency. Does anyone know what frequency means in this context?
How frequent something happens.
Yes, correct.
He just said, he was not thinking about that.
No, I didn't.
You are correct, though. It is.
Yeah.
It's what
It
you
is
think
like-
when you say. So
Yeah.
say you're like, oh, what's the frequency of the Super Bowl? Once per year. What's the frequency of, say, a Sunday? Once per week. Or maybe you could say 52 times per year. Are there?
Well,
Is there guaranteed to be 52 Sundays every year?
I don't know, let's count.
There's 52 weeks in a year, but you're not guaranteed that.
Because they don't always start on Monday.
Yeah.
Or Sunday.
Paul, is the frequency here like how many times it passes a certain point?
Yeah, it could be something like how many times does it pass this point per second? Really, it's how many times does a thing happen per second. And you might be thinking, well, why do it per second? It's not really hard. That's just the way we're going to do it with physics. It's like the second is our core unit of time. So frequency is defined. It's in this context, it would be revolutions per second. How many revolutions happen every second?
So this, on the Sunday one, it says that there's 52, but it's like there's one extra day in a year, right? So it's 52 Sundays, but then every 7th year is 53rd.
Oh, so you are guaranteed at least 52. Okay, sweet. Anyway, it's just how many times, how many cycles per second. Have you ever heard I'm sure you've all heard the word like megahertz or gigahertz at some point? I'll get to that in a second here. So how many revolutions? 300. All right, there's 300 revolutions over how many seconds? 60 seconds. So that's 5 revolutions per second. Now there's a nice unit for that. Does anyone know what unit would be like cycles per second?
Or RPS.
You could write that as RPS, yeah. But a physicsy one is what?
Hertz.
Hertz. For $100, who came up with the unit Hertz?
Arnold E. Hertz.
Hertz, Mr. Hertz.
The guy who started Richmond?
Yeah.
Actually, I don't know if that's true. Did I tell you guys about the Stigler's law? How like a lot of sciencey things that are like named after a certain person were actually discovered by someone else.
Yeah.
For example, Euler was one of the most prolific mathematicians in human history. Euler came up with all this cool stuff. But guess who discovered Euler's number? The famous Euler's number, E? Bernoulli. Crazy, right?
Einstein.
No, not Einstein. Anyway, you can look up on Wikipedia, Stigler's law has this long list of laws that were like, Smith's law. Who discovered Smith's law? Oh, it was Jones. Another person.
So who just you have a
Bernoulli's
Stigler?
law, or number does not roll off the tongue like you.
Okay. So do we understand then, hopefully, just what that means? So, oh, by the way, I said I'd mention it. So if you're talking about like megahertz, what is something that says, oh, this signal is 5 megahertz? Well, what does mega mean? I failed you all, I'm sorry. Mega means a million, 10 to the 6th. So, here. Maybe if I write it down again, you'll remember. Mega is 10 to the 6th, that's a million. Giga is 10 to the 9th, a billion. So if you're talking about a signal, what kind of object can oscillate back and forth 1,000,000 times per second?
Laser light.
Yeah, things like photons, electrons, very tiny things can do that. So yeah, like a light, a wave of light can go peak to valley back to peak, basically, billions of times every second. Depends on the wavelength of the light. You guys all have seen this, right? I mean, probably like middle school science, like that's the speed of light, and so the wavelength of light, and then the frequency of light. So oh well, there you go. There you go. It's a very fundamental equation. The speed of light in a vacuum is constant. It's about 300 million meters per second. So what this tells you is that the longer the wavelength, because you guys know how light works, right? You got like
If you were to put a circle
Yeah, like radio waves are really long. So if you have a big wavelength, like a radio wave, then your frequency is small, because that's a constant. And if you're down here, you can get like visible light. What's really crazy is everything we can see with our eyeballs is in this tiny little band, a skinny little band of like something like 400 nanometers to like 900 nanometers, roughly. You can fact check me those numbers, but this tiny little band of light is all we can see. All the other electromagnetic radiation, you can't see it. Anyway, so all I was saying is, you can, if you know the wavelength of your light, you can plug your wavelength in, say 600 nanometers. I'm not sure what that is. It might be blue or something or green. So you can plug in 600 nanometers, 300 million meters per second, and you can calculate what's the actual frequency of that light wave. How many times is it oscillating every second? So, okay.
Oh, have you ever tried to imagine new colors?
Yeah.
I was actually. I know. Yeah. It's like tough to do, but it's like kind of fun.
There was a person on Big Mountain on Saturday that was wearing this like suit.
Yeah.
That was this crazy like iridescent blue, like it's like a metallic blue, but it looked like it was great. It's what I would think about if you could like experience a new color. I'm like, that's what it would be. It must have been some crazy. There was a full. You didn't see him? Full body suit. It was like the craziest color I've ever seen. But anyway,
I saw a guy make a chrome one.
there you go.
So blue rock.
This one was kind of chrome-like. It was kind of chrome, kind of not, kind of blue, kind of red, kind of silver. I wish I had taken a picture of it.
Jackets, you like look like they're dim lights constantly.
Oh, yeah.
I saw-
like the reflective.
Yeah, the weird reflective
I
ones.
saw a funny junior high kid in one of those big like onesie suits, and that thing was like right through the floor. So like his mom did not want to lose that.
All right, let's move on here. So period, capital T used for period. The choice of letter is a small hint that's describing amount of time. So the period is how many seconds does each revolution take? Which look at that. What's then the relationship between T and F?
Inverse.
They're close. They're reciprocals. So the period and the frequency are reciprocals of each other, right? So, like in this case, you'd end up with, you could calculate it like this. You could say, oh, it took 60 seconds to complete 300 revolutions. So that's a 1/5. Now, the way you usually write it though is you just say the number of seconds. So a period is going to be a time value. You could write it as seconds per revolution, but it's more standard just to write it as how many seconds. Then everyone kind of just knows you're talking about that's how many seconds it takes to complete one cycle. Okay? All right. And then when you're describing a system, it's all context dependent on like, what are you going to talk about, the period or the frequency? Well, you tell me. What do you think? What kind of systems do you think you're more likely to use frequency to describe them? Fast or slow systems? Fast. If something's doing a lot of jiggly wigglies, right? It makes more sense to be like, oh, it oscillates 100 times per second. That makes more sense usually than to say, oh, it has a period of 0.01 seconds. Whereas period makes a lot more sense if you're talking about something that takes a long time. Like, what's the period of Earth's orbit around the sun? A year. It could be periodic. Usually it's for periodic things that happen. But does that make sense? What's the period of the moon going around the Earth?
It's one
Right.
28
A month.
One day.
What's the period of the Earth rotating around its own axis?
23.
A day. A day.
You got that one, Cable.
Right?
Proud of yourself.
Maybe? Do you understand? Okay. All right. Let's keep going here. So how about angular velocity? What the heck is that? I'm just gonna trigger someone here. What letter is that? Wrong. Got you. That's for TikTok. You just got TikTok. It's called omega. Actually, it's omega. Yeah, it's the lowercase omega. So in the Greek alphabet, there's that's omega, but also this.
Oh my god.
Is that an owl too?
No, that was okay.
No, I just.
Oh my God.
Oh, wow, good, okay, good one, kudos. So, omega, okay? That's the letter, omega, okay? So, omega, so what do you think? So if normal velocity is like meters per second, take a guess. What do you think angular velocity is gonna be talking about? Very close. Radians per second. Radians per second. So this is how many radians per second. Okay. So how do we figure that out then? Well, we know how many spins per second, right? How many spins per second on this?
Oh.
Come on.
Each of those spins has how many radians? 2 pi. So how many radians per second then? 10 pi.
Oh my God.
5 multiplied by 2 pi. It's okay. You're saving all that energy for the race.
Getting it for
You're-
this going to parks.
You're in a hibernating state.
Saving it for that thing he has to do later.
So the number of radians then, so think about where this comes from though. This is an important thing here. Because what we did was we took we multiplied 2 pi by 5, right? Sorry. Because this is a really important formula to know for all the stuff we're gonna do. So the answer to this was 10 pi. How about units? The units would just be radians per second. But the big thing here, the thing I really want to stress here is what we just showed is that the angular speed is just 2 pi times the frequency. That's like a really good one to know, okay? This unit that we're doing is a good one for you studiers out there. It would be a good one to make a couple note cards for, because there's a lot of everything's going to be like 10 times easier if you just can quickly recall that, like, oh yeah, omega is 2 pi f. And what else? What about the relationship here? What would we say for this? The frequency is the reciprocal of the period, right? Does that make sense?
Yeah.
And vice versa. That's true. Also, T is equal to 1 over F as well. That makes sense? So now, of course, these are the exact same formula. So T and F are reciprocals. Omega is 2 pi times your F. And then the last one we got to cover is, what does this have to do with speed or velocity? Well, because I want to end up, the goal here is really to end up with a nice formula for how does V relate to this other stuff. But do you see how the velocity, you could calculate it as just how far does he travel with each spin? What's the formula for how far you travel in one rotation? Circumference, 2 pi r, right? So you could go like 2 pi r, right? But then you have to multiply that by what? Sorry, Matt. So this, what I just wrote there, that's how far you travel in one rotation. And then what else do we know? We know
How many rotations per second?
we know how many rotations we do every second. So therefore, if you multiply this by 5, that makes sense? You'd get, so that's 10 pi times the radius, which is 3. So 30 pi. What are the units of this guy? Meters per second. Now the really important thing, this is the purpose of the problem, is to end up with this last result here, which is the stuff in red is actually the big purpose of the problem. So the velocity really, see that 2 pi f? which is omega, right? Omega is 2 pi f. So the velocity was really just the angular velocity multiplied by the radius of the circle. This is a really important formula to know for doing this stuff. So does that make sense?
Yep.
And certainly you could write this as V equals 2 pi f times r if you really wanted to. But this is a nicer way to write it. So, oh, and by the way, this also reinforces that idea of this. Remember this one? Like that. Well, what if I take this and divide it by time? Meters per second velocity is equal to radians per second, omega, times radius. So that's another way you could have gotten there, just by manipulating that formula. Okay, well, have I sufficiently crushed your souls, bored you to death this fine morning? Okay, good. There, job well done.
I'm already looking forward to that.
I can't wait till I don't have to be here.
Wow.